You likely have a feeling of sitting perfectly still right now. The chair beneath you and the walls around you feel solid and unmoving. But in a physical sense, that stillness is an illusion. Modern relativity dictates that velocity isn't an independent property of an object. Because there is no stationary center of the universe to measure against, speed is strictly relational. You are only moving relative to something else. This means the Earth doesn't follow a single, simple path. Instead, we exist in a compound kinematic state, a collection of overlapping motions that shift in direction and magnitude every second. To find our speed on a specific date, like May 10, 2026, we have to zoom out through 4 distinct scales of reality. At the furthest edge of that calculation, astronomers have recently encountered a measurement that the standard model of cosmology cannot yet explain. The first scale is geocentric, the rotation of the planet itself. At the equator, the Earth's surface is spinning at approximately 1,674 kilometers per hour. That is nearly 1.5 times the speed of sound. This speed decreases toward the poles, following a mathematical decay. At 45 degrees north, it drops to 1,184 kilometers per hour. But Earth isn't perfectly rigid. The sloshing of its molten core and melting polar ice cause this rotation to stutter by milliseconds. Pulling back to scale 2, we see the Earth's orbit around the Sun. We are traversing the solar system at a mean velocity of nearly 30 kilometers per second. To put that in perspective, at 30 kilometers per second, the Earth travels its own entire planetary diameter every 7 minutes. Our localized sense of scale is effectively eclipsed by this orbital reality. Scale 3 moves us into the Milky Way. Our entire solar system is orbiting the galactic center, following a reference frame called the local standard of rest. We are currently hurtling through the galactic disk at roughly 250 kilometers per second. It takes 225 million years to complete a single galactic orbit. The last time the Earth was at this exact physical coordinate in space, the very first dinosaurs were just appearing in the Triassic period. This motion is seasonally dynamic. Because Earth's orbit is tilted 63 degrees relative to the galaxy, points in the year exist where our speed adds to the Sun's motion and points where it subtracts, causing our net galactic speed to oscillate. But even the rotation of the Milky Way is just a localized movement, caught in a much larger intergalactic current. Scale 4 brings us to the largest reference frame available, the cosmic microwave background. This is the relic radiation from the Big Bang, which fills all of observable space. Moving through this radiation creates a Doppler effect. The radiation looks slightly warmer ahead of us and cooler behind us. This dipole reveals our entire group of galaxies is in a bulk flow toward the Shapley concentration at roughly 620 kilometers per second. Adding all these vectors together, the standard model of cosmology suggests we are moving through the universe at a total speed of 2.23 million kilometers per hour. That 620 kilometer per second figure has been the consensus for decades, but observations compiled in 2025 and 2026 have revealed a severe discrepancy known as the cosmic dipole tension. When we track the motion of distant physical matter, like far-off radio galaxies and quasars, we get a different result. These surveys show us moving at over 1,000 kilometers per second, nearly 3 times faster than the speed suggested by the background radiation. One proposed explanation is the alignment framework. It suggests the universe itself is drifting. While massless radiation moves freely, bound structures like our galaxy lag behind. This means the rest frame of matter and radiation are no longer in sync. This mismatch has reached a 5 sigma level of statistical significance. In cosmology, that is the gold standard for a genuine physical anomaly. It suggests that our fundamental assumptions about a singular true speed may be incomplete. As you sit in your room, you are participating in a multi-axis dance through a complex cosmic web. Whether you measure your speed against ancient light or distant galaxies, the answer reveals a